So, welcome back, students, and let's move on to the fifth part of our lecture. That is part 2 of the fourth part of our lecture. So, before we start, let me introduce you to one guy, one close friend of mine. So, I already told you about Ashish Kungulu. So, this is not Kungulu. This guy is. This guy, the guy with the big mustache. His name is Dr. Manu Peringattu. Yes, a weird name, I know, but he wa- okay. Anyways, so he is a designer. He was a designer by profession, but then he decided to quit designing, and then he went on to teaching, and then he became a professor, and now he's a principal of a school. So recently, I was calling him and telling him about how I started teaching class 11 students, and we were having a good conversation, and then he told me about the students in his school who are also be in class 11th, who are studying physics, chemistry, and maths. So then he gave me a list of all those students. So let me show you the list of physics, chemistry, and maths. So these are the students in physics, and of course same students came in chemistry also. Rajapan, Dankapan, Kunyapan, Sarama, Shoshama. Then Max, he gave me a list where almost the names are similar. Rajapan, Tharama, Kunyapan is same, but here two names are different. Kunyapan and Mariama. Wait, let me take my pointer here. Kuttappan and Mariama. These two names are different. Unique. It was not in these two lists. So I asked him why, and he told me that these are commerce math people, so they study maths together. Anyway, so maths is same for science and commerce, so they study maths together in one class. And I said okay. So I thought of, anyways I was teaching a set, so I thought, why don't I tell these to you and tell you to make a set of all these things, all these people. For example, this A, set A. For example, this is set B, and for example, this is set C. I want you guys to tell me what will be A union B union C. That is, I want you guys to do a union operation here with all three sets. So I try to do, and so the one way of doing it is, just writing all the names. Just write 1, 2, 3, 4, 5, 6, 7, 8, 10. Just include all the names. So I included all the names in order. Rajapan, Dangapan, Kunyapan, Sarama, Shosham, and I kept going like that. But then I realized that there is a big issue. This is a class list. How can I have Rajapan, Rajapan 3 times? 3 Rajapans are there. No, there's only one guy who's called Rajapan. How can I have his name 3 times? So there was an issue, and I saw that many names are repeating, and that cannot be done, right? In a class there cannot be 3 names when there's only one person like that. So then I understood this is not the right way of doing it. So the problem is here things are repeating, so names are repeating. So now I want to introduce you to another concept in math, that is, in sets, that is the concept of no repetition. When you unite two sets, when you do the union operation, 2 or 3 or how many ever sets you want depending on your time, one thing that you should always make sure is that you do not repeat the elements, because every element in a set has a unique identity. It's a unique thing. You cannot repeat it. Repetition will make it lose the uniqueness of that element. That is, when I am making a class list now, in this example, it would be like this: Rajapan, Tangapan, Kunyapan, Sarama, Shoshama, Kuttapan, Mariama. 7 names. See, instead of 15, now it is 7, because I excluded all the repeating ones. Right. So So what I was trying to tell you is there is no repetition in the elements of a set. All the elements of a set are unique and it cannot repeat. So whatever be the operation, whether you are doing a union operation, subtraction operation, I know I have not taught you subtraction, that I will try to do it today. Subtraction or intersection probably you won't get any repeating elements. But whatever be the operation you do, whatever be it, complement, whatever be it, we should never repeat the elements in a set. Okay. Now let me give an example. I have a set A and set B of this kind. A is equal to 2, 4, 6, 8, 10, 12. B is equal to 1, 2, 3, 4, 5, 6. I am now asking you to do a union operation here. A union B. What will be the answer that you're getting? So two ways of writing. One way is 1, 2, 3, 4, 5, 6, 8, 10, 12. Another way of writing is 1, 2, 3, 4, 5, 6, 2, 4, 6, 8, 10, 12. That is, I am putting these elements here and I am putting these elements here. So tell me which one of them is right. Here I can see that there are repeating elements. 2 is repeating, 4 is repeating, 6 is repeating. So here this is not a set. This is not a set. We cannot call it a set. Why? Because in a set every element should be unique. There is no uniqueness here for 2 because this 2 is coming here also. So in that case we can decide that this is not a set. What is the answer? First one, 1, 2, 3, 4, 5, 6, 8, 10, 12. So this is what I wanted you to know, and if you remember right, this was the third question in the first assignment which I gave you. Third question, the first assignment which I gave you had this: D is equal to a set of elements X is such that X is a letter in the word loyal. Okay, X is such that X is a letter in the word loyal. A very usual way and a very common way of writing it would be LOYAL, the set of 5 letters. But here there is an issue. Why? Because L and L is repeating. That is an issue. We cannot have these repeating letters here because that destroys the definition of a set. In a set, each element should be unique and only be mentioned once. So what we do here is so that means this is the wrong way of writing. So what is the right way of writing? Maybe Loya, L-O-Y-A, or maybe you could write it as Yola, Y-O-L-A, or maybe you can write it as ILO, A-Y-L-O. You can write it as any order you want. Remember, you can rearrange the elements in a set in whichever order you want. But the thing that you should take care is that there should not be any repetition. That is something that you should take care. So let that be it for now. Let us move on to so now we will move on to now we'll move a little more deeper into understanding the operations that we do with sets. So let me change my platform. We studied about union, intersection, complement, and those blah 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 things class. So today we'll what I want to do was to dive a little more deeper into these stuffs, into the operations of which we studied last class. So to start with, so here I'm going to ask questions and I know that I myself will be giving the answers, but still I want you to think about these questions before you see what the answer that I will show. Okay, so one thing is we studied about a set, we studied about a intersection, complement, all that thing. Now what will be, suppose I'm putting a set A, I am putting an empty set, and what if I am uniting them? A union empty set. What will be the answer? See, empty set has nothing in that. It's an empty set, as its name suggests. Phi, A union phi. Now, if you add 0 to anything, what difference will it make? Does it make any difference? No, right? So A union phi will be the same thing, A itself. Okay, that is one thing. Now, suppose instead of union, I wanted to do a intersection phi. A intersection empty set. What will it be? See, every set, if suppose I take a set, every set contains 3 types of subsets. Not 3 subsets. Every set contains 3 types of subsets. That is 1, 2, 3. 3 types. One is an empty set. Every set contains a empty set as a subset. Right? Now, why it contains empty set as a subset? Because if I do A union phi, it still becomes A. That means this part, even after I join to A, it still becomes A. That means this part is always there with A. Okay, let it be. I don't want to confuse it. Let it be. So A intersection. Every set has an empty set as its subset. Then you can rearrange the elements in whichever way you want, and you can make another many subsets like that. Then the full thing, basically the whole set will be there as a subset. The empty set is there as a subset, and then whatever the elements are there, you can rearrange in them in different orders and different combinations. Not orders, sorry. You can rearrange them in different combinations, maybe 2 elements or maybe 3 elements or maybe just 1 element. So you can get many subsets as you want. So that is one way of doing it. So that is a way of doing it. So this part, so when I say A intersection phi, we should understand that phi is already there in the set A, right? So what is A intersection phi? What is the common thing between A and an empty set? Nothing but an empty set itself, right? There's nothing common between A and nothing. Empty set is basically nothing. There is nothing common between A and nothing. So what is the answer again? The answer again is phi. Now remember that this is also called identity element. Why? Because you do intersection with phi, or you do union with phi. You do union with phi, you get the same element. For example, A union phi is A, right? So you get the same element. That is why this phi is called identity element. Okay, now let that be it. I want to move on to something else here. Suppose I have a universal set. Now whenever you write universal set, I want you to write it like this. Don't write it like this. This symbol is for union. This symbol is for union, and this symbol is for universal set. This will be your universe, and this will be your union. Okay, I was supposed to draw a Milky Galaxy, but it looks like a amoeba now. Okay, anyways, so because both are in the shape of U, I don't want you to be confused, and I don't want I to be confused when I am correcting your papers. So let us follow this convention in our maths, in our classes. That means this is universal set, this is the operation union. Okay, now, so the question that I have is, I have a set U, and I want to unite I have a set universal set, and I want to unite it with A. Universal set union A. What will be the answer? Let me draw a Venn diagram. I am drawing my Venn diagram. I'm drawing this. So this is my universal set. I'm drawing my set A. Then I am naming it A. So this is my universal set, this rectangle, and that rectangle contains the set A. So I cannot add anything new to it. So whatever is already there in universal set only you are uniting. So therefore universal set remains the same. Whatever you unite within it. The universal set whatever means whatever inside you unite with it. So universal set union A will be again universal set. Okay. Now suppose instead of this, suppose instead of the union, suppose I wanted to do intersection. Suppose I wanted to do intersection. What would have been the answer? Universal set intersection A. What will be the answer? Again, let us draw the concept of Venn diagram. Venn diagram is, this is why Venn diagram is so useful. Venn diagram, this is my universal set, then I draw my set A. So what is that is common between universal set and A? This whole thing is my universal set. This is my set A. Let me draw a darker color. This is my set A. So what is common here? A. So universal intersection A. See, this is where both the colors join, right? So universal intersection A is again what? A. Okay. Now let that be it. Again, so now I want to move on to something else. So here I'm going to show you little more questions. That is number 1. A union B the whole complement. Not A complement, not B complement. It's A union B. A is one set, B is one set. I'm uniting them to make another set and the complement of that set. So again, let me draw my Venn diagram. My Venn diagram is the best way of explaining all these things. So I'm drawing my Venn diagram here. This is my universal set. I put my set A, I put my set B, and I name them A, I name them B. Now the A union B, the whole complement. Let me first draw A union B, then you will understand what is not that. So A union B is this one. This is my A union B. We learned that last class. This is my A union B. This is my A union B. Now this is not my question. The question is not A union B. The question is A union B a whole complement. So what I need is basically the whatever I have not shaded. Whatever I have not shaded is what I need, because what I need is complement, right? So let me go for that. I'll take a color red and I will shade this part. So this is my part which I have not shaded before. So this is my A union B, the whole complement. Okay, so this is my A union B, the whole complement. So this thing is not there. See, so when you shade, you do not shade A union B. What I want, when I ask you to draw a Venn diagram for A union B whole complement, it will be like this. A union B, whatever is not A union B is shaded. Now let that be there. Now what I want to do is another thing. So I have another question now, that is, let me change my color, I don't want to destroy your eyes. So okay, A complement intersection B complement. Draw a Venn diagram for A complement intersection B complement. How am I supposed to do that? So Venn diagram, again to the rescue. My universal set, my set A, my set B, then I name them A, I name them B. So let us go step by step to begin this. First the thing is A complement. So how I'm gonna, so let me shade, I will use the red again for that. So I need A complement. So what is A complement? Whatever is not A. So let me draw that. Whatever is not A, let me shade whatever is not A. This is my A complement. This is my A complement. Cool. Okay, this part also. Okay, now this part is done. Now what I need is B complement, right? So let us go for B complement. Let me use another color. Let me use blue for that. Okay, now I will shade everything other than B, and that will be by B complement. This is my B complement. Everything other than B, right? Now the question, so this part is also done. Now the question is not A complement or B complement, but the question is A complement intersection B complement. So what is intersection? The part where A complement and B complement interact. So if you look, where all do the red and blue colors coincide, or where all do the red and blue colors come together? Here it doesn't come, here it doesn't come. I mean, only it comes at the, or it doesn't come inside the circles, it only comes outside the circle. See, all this area. So let me shade the area where both the colors come together, and that will be, I will take white, the color white, and I will start shading. So this is the area where both the colors come together. Both the colors come together at this area. See, so this is, so let me take off the other part. So this is the part, okay, I'll take that later. This is the part, this white colored part is the intersection part. So I showed you what is A complement, I showed you what is B complement, and I showed you the intersection between A complement and B complement. So let me take the other part off. I'm sorry. So so let me take the blue part off, and that will be okay. If I take that, this rest of things also will go. So I hope you understood that this part is the, now if you see carefully, this part looks like something else. I mean, it looks similar to something else that we saw just now. Just look back, you will see. If I take this part up, and if I take this part up, and if I show you these stuffs, see, now look carefully. Do you see that things are common? In both the cases, what we did was, or if I show you this part like this, and if I move this part here, see, in both the area, in both the cases, we saw that the first question was what? Both the cases we see that the shaded part is the same. But what is the question? What is the first question was this one. This one was A union B the whole complement. That is this one. Now what was this one? A intersection A complement intersection B complement. What did we come to we realize now? Both are the same. If you look carefully, both, see, if I take this part off, if I take this part off, if I take this is the unshaded. If I take this part off, you will easily understand. If I take this part off, you'll see that the shaded portion is almost the same. The shaded portion is almost, this is A, this is B, the shaded portion is almost the same. Not almost, it is the same. So we have come to another property. This is a property listed in your book, but instead of learning them as a separate property, you can always find them out like this. This is a proof that both of them are the same. Now let me not all these things again for you. I'll note all these things again for you. That will be so what we saw here was, we saw A complement intersection B complement is equal to A union B whole complement. Now this law is called, this law is called Demorgan law. This portion is called Demorgan's law. Okay, this Demorgan's law doesn't consist of this thing alone. It consists of one more thing, that is, it consists of A union, A intersection union B intersection is equal to A intersection B the whole complement. Okay, these two things are called De-Morgan's law. Now I don't want you to study them by heart. It's very easy to, I'll tell you an easier way. So these two are the things, you will find this in a textbook. An easier way to look at this is, De-Morgan's law will be, now one A union B the whole intersection. You apply the complement, sorry, A union B the whole complement. You apply the complement symbol in both the sets. Put the complement symbol here and put the complement symbol here. It will be A complement and B complement. Now invert this universal symbol, sorry, union symbol. So it will be intersection. This is one law. The second law is A intersection B whole complement. A intersection B whole complement. Here too, using the same principle, you apply this complement on both A and B, so that will be A complement, B complement, then invert this symbol, so it will be union. So this is the second law. A intersection B the whole complement is equal to A intersection union B complement. Now I proved you this by Venn diagram. This one I proved. This one I want you to prove by Venn diagrams and submit it to me in the assignment. I'll include that question in the assignment. Now I know this might sound a bit difficult. I'm not sure how you're taking it or whether you understood this. If you're not understood this, please get back to me, contact me in some other way, tell me, and if needed, I'll make yet another video for this. But anyways, let me know. If you have understood this first proof, then I'm sure you'll be able to do the second one also. So try doing that by yourself. Do not look into the text, do not look at any other sources on the internet. Try to do it by yourself, because this concept of Venn diagram is pretty important. It's very important in the chapter sets and in the coming chapters also, because if you know the concept of Venn diagram, you'll be able to understand functions and the extent of functions. See, if I use those terms, you won't be able to understand them now, so I don't want to use them. But later in the coming, even in 12th, even 11th, I guess, even 11th and even in 12th, there are portions you won't have a separate chapter called sets, but the concepts that you're studying here will be used there. So if you are very thorough, if you are very thorough with the concept of Venn diagram, it will help you a lot in the coming topics. Okay guys, thank you for listening. God bless.